Thank you for joining this lesson. I want us to learn a concept called total internal reflection. Under total internal reflection, we have to analyze a few things here. We must know that there are conditions to be met for total internal reflection to occur. Basically, refraction occurs when light traveling from one medium enters another medium, whereby there is a difference in the optical densities of the two media. So if we have media 1 and media 2 here, and media 1 again and another media 2, or we can have media 2 then 1. If light travels from media 1, then on reaching the interface, this is the normal, we realize that media 2 is denser than media 1. The ray of light will get refracted towards the normal. That's how the ray will behave. But now if media 2 now is optically denser than media 1, when the ray of light approaches the boundary, we will have refraction away from the normal. Refraction away from the normal. So now this gives us now the basis of total internal reflection. So if we continue increasing the angle of incidence here of the ray, there reaches a point whereby, because this angle of incidence, as we increase it, the one for refraction is also increasing, such that it will reach a point whereby when the angle of incidence is great enough, this angle of incidence I is great enough, the angle of refraction, will increase until it becomes 90 degrees, and the ray is going to follow this path. The ray is going to follow this path. So upon such a scenario, any further increment of the total of the angle of incidence in the denser medium, because this, we said this one is the denser, this one is the less dense, this one is the less dense, this one is the denser. Therefore, further increment of the angle of incidence in the denser medium will lead to the ray now getting reflected back, bouncing back in the same medium, such that now on reaching the interface, the ray bounces back to the medium where it was, and it doesn't penetrate the second medium. Therefore, we say in such a scenario, total internal reflection has occurred. So we have some conditions which are necessary for total internal reflection to occur, and one is that light must be traveling from the denser medium to the less dense medium. Because if it happens the other way around, from a less dense to denser, the ray of light will get refracted towards the normal, and there is no chances of a reflection occurring. But now, if it is from the denser to the less dense optically, the ray gets refracted away from the normal, and there are chances of finally having total internal reflection. And now something else should come to our mind, that there is the angle of incidence which we are increasing until at some point the angle of refraction becomes 90. Now at that point, further increment on the angle of incidence leads to occurrence of total internal reflection. And now we are saying that angle of incidence in the denser medium, for which the angle of refraction in the less dense medium becomes 90, we say that such angle is called the critical angle, small letter c. So critical angle is the angle of incidence in the denser medium for which the angle of refraction in the less dense medium is 90 degrees. Now we must say another condition necessary for total internal reflection to occur: the angle of incidence in the denser medium must be greater than the critical angle, because it is now beyond critical angle that total internal reflection occurs. So that is how total internal reflection occurs. Two conditions: light from the optically denser medium to the optically less dense medium, and angle of incidence in the denser medium being greater than critical angle, because before critical angle the angle of refraction will be lesser than 90 and there are no chances of total internal reflection.